Okay, so in this video we're going to have a look at inverse proportion in context. Now these questions are the ones that students tend to really dislike. So this one here, don't forget there are lots of videos in the description that you can find. So if you want to have a go at this, then feel free to pause the video and have a go. But otherwise I'm going to quickly show you where you can find more of these types of questions. So when you're on one of these videos, if you click into the description, you'll see that I've got everything listed within there. I've got hard questions to try, I've got checklists and practice papers that you can download, and other questions and other videos within this series. Now if you scroll down to the bottom of the description, you'll see down there it says topics featured in this video. So in there I'll put all the links with difficult questions and topic videos related to this topic right there for you to access. So just click onto one of those and it will take you on to more practice questions and different versions of this topic. So with that being said, let's get started. Okay, so let's start by reading this question. It says a company orders a number of bottles from a factory. The 8 machines in the factory could make all the bottles in 5 days. All the machines work at the same rate. Then it says for 2 days only 4 machines are used, and from the 3rd day all 8 machines are used to make the bottles. Work out the number of days, or the total number of days, taken to make all the bottles. Now we've got to kind of think of this in a slightly different way. Now we can do this using numbers, which I'm going to do as well, or we can think about visualizing this. The way to visualize it will help us to understand the numbers, but we want to make sure that we can do this just using a numerical method, obviously in an exam situation. So if we start, let's think about each machine. Now let's imagine that each machine, and let's just say that every day's work it does costs £1. Let's just say £1 just to make it nice and easy. So how many pounds am I going to have to pay to run all these machines for the 5 days? Well, if I've got 8 machines running, I'm going to have to pay £8 per day. And I'm going to do that for 5 days. So let's just imagine this in terms of a picture. So I've got 1, 2, 3, 4, 5, 6, 7, 8 on the first day. And I'm just going to replicate that for each of the 5 days. So this is how much it's going to cost me in pounds. And again, you might not like this picture method, but I'm going to have to go to the start here. If you don't like these types of questions, it might just help you to visualize why we do what we do. So that's how much it's going to cost us. Now, if we do that in a numerical method at the same time, to work out that amount of money there, we would just take those two numbers, 8 machines and 5 days, and multiply them. So 8 machines times 5 would take us to £40, or in terms of our number, that actually represents 40 days that it would take one machine, and that's where this inverse proportion comes into play. So 8 times 5 tells us that one machine would take 40 days, but we don't have one machine running. So it says for 2 days, only 4 of the machines are used. Now that means on the first 2 days, we would cross off, well on the first day, we'd cross off 4 of these, that's £4 done. And on the second day, we'd cross off another 4. So in total, we've crossed off 8 of them. Now what we could do numerically is we can say, okay, well 2 times 4 equals 8. And effectively that means we've done 8 of those days of work, or in relation to our money, £8 has already been done. So we've done 8 and we started off needing 40. So that means if I do 40, take away the 8 that we've done, we've got 32 days worth of work left. Or in other words, with our picture here, I've still got £32 worth of work to do. We've got 32 of these dots left, so 32 are left. But we have done 2 days of work. Now it says from the 3rd day, so for however many more days it's going to take, all 8 machines are used. Work out the total number of days. Well, that means on the 3rd day, we can cross off all 8 of those. On the 4th day, we can cross off another 8, because that'll be another 8 machines being used. On the 5th day, we can cross off another 8, and on the 6th day, we can cross off another 8. And you can see there on that 6th day that all of those circles are crossed out. Now mathematically, what we can do, well, we had 32 days worth of work left, so 32 days divided by the 8 machines that we're going to use ends up being 4 more days. So we had 4 days of running those 8 machines. And we get our number 6 there because we started off with the 2 days where we were running 4 machines. We then had 4 more days, so we have 4 plus 2, which gave us a total number of 6. So it was 6 days in total to complete the job. Now we can see that from our picture as well. So we started off by having the first day just there with those 4 machines, and then we had the second day using those 4 machines, and then we had our 3rd, 4th, 5th, 6th day using all 8 machines. Now you may not like that picture method, but not everybody likes this method of just doing it with the numbers. So if that picture method helps you to think about it in a slightly different way, then that might be a good useful method for you. But ultimately, the numerical method is going to be a lot faster, particularly if this number is a lot more than 40. 40 was just about okay. As you can see, I could just about fit them on the screen there, but this method here, using the numbers, is what we want to try and get our head around. So when we had the 8 machines for 5 days, we did 8 times 5, which was 40 days, and remembering that linked to 40 days for one machine. So if one machine was doing this job, it would take 40 days, and that's the key part there for our inverse proportion. Now, if the next statement just said, well, instead of using 8 machines, they're going to use 5 machines, how long would that take? Well, you would just do 40 divided by 5, and it would tell you that it would take 8 days. But this question is more difficult because this is splitting it up. We had for 2 days only 4 machines are used. So for that that was actually only equivalent to 8 days of work. So before dividing it by the 8 machines in the next step, we had to first get rid of those 8 days that had already been done in the first 2. So these are quite complicated questions, and they're called inverse proportion in context. Again, I will link the full video in the description, so do have a look at that if you're not sure. You can always come back to this question, try it back out again. But otherwise, I hope that was useful and helpful. If it was, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.